Check, check. Start streaming. I should always check this. I'm glad I did. Okay, so, yep, there we started. So again, real quick, just for the video's sake, there's the our success criteria for today. If you can do these things, then you got out of what we needed to do today well. Okay, so let's go ahead and get started with the rational zero theorem. It looks crazy. I know I heard somebody grunting. Please don't grunt, okay? When we're trying to find all the zeros, and like I said a minute ago, last time we met, we saw they gave us the one of the zeros, right? They said, oh, one of the zeros is 1, or it was, I don't remember what it was. But here's a 0, and then we were able to do synthetic division. Our remainder ended up being 0, and we were able to get a quadratic that we could factor at that point and then find all the zeros, correct? And that should be in the recording somewhere from the last time that we met. And it looks kind of crazy, but it's really not, okay? So what is the first part we're looking at up here? Anybody remember what this is? Standard form. Yeah, all this is the standard form of a polynomial. So what you want to do is you want to put it into the standard form. And our possible zeros are going to come in the form of what's called the p's over q's. And they have to be in reduced terms, okay? The p's are the factors of the constant term. And the q's are going to be the factors of the leading coefficient. And that's all that is. All the factors, okay? And like I said, it's a little bit tedious, but it's not a big deal. So let's take a look at an example here. And please just watch me do this. Reminder, your cell phones out of sight, please. I don't want to see those out. Oh, wait a minute. You guys take pictures sometimes, don't you? Okay, my bad. If that's what you're doing, then that's okay. I apologize. I forget. I try to get on those rules all the time, especially with my freshmen. Anyways, let's get back to here. So I have this 5th degree polynomial. Oh my god! 5th degree. I'm going to have to find how many zeros at most? 5, right? I can't factor that, obviously. So I'm going to have to use my synthetic division, and I'm going to have to find some possible values. Because obviously, what's going to go here? 4, 12, 0, 0, -1, -3, correct? But the question is, what am I going to try out up front to try to get those zeros, right? So that's what we're after. That's the idea. So let me tell you the possibilities here. Guys, this is my constant term. It's already in order. That's my constant. What are all of the factors of 3? 1 and 3, right? And what we're going to do is we're going to do plus or minus 1, plus or minus 3. Okay, because -1 times -3 would also give me a 3, wouldn't it? Everyone okay with that? Oh, not a big deal, was it? Now we're going to find all the factors of the leading coefficient. In this case, 4. So I'm going to get plus or minus 1. What else? 2. Plus or minus 2 and plus or minus 4. So what I've done for myself is created kind of like this bank of possible zeros. Okay? Let me tell you how to extract them. It's going to be every combination of numerator to denominator. So, for example, 1 over 1 is 1, right? So I would need to test positive 1 and negative, whoa, what do they do? I would want to test a positive and a negative 1. And I would also want to test positive and negative 1/2. I would also want to test positive and negative 1/4. And then I'm going to go to the other value. I'm going to want to test plus or minus 3. This, which is 3 over 2. And then finally, plus or minus 3/4. So, yeah, that is a lot. You'll quickly learn that. No, hold on, that was hard? If that part was hard, then.
You're going to have to do synthetic division with all of those, though?
The answer is no. So, like I was saying, you'll quickly learn that you want to try out your 1s and 0s first, maybe your 3s, your integers. Once you find that those are already there, and if you've gotten down to a quadratic, then once you're at quadratic level, do you still want to keep doing synthetic division? No, what do you want to try out? Factoring or quadratic equation is not factorable. But yeah, you're going to want to try some of those. What's kind of nice is some of the synthetic division goes by pretty fast. You guys remember when I did it yesterday? It was pretty quick. So I'll let you guys write those down for a second. Because I know you guys want to get those, right? Some of the questions that you'll be asked simply are, what are some possibilities for the zeros? And you'll have to make a list of 12 items. I have 6 because I kind of jumbled them in there. Oops, that's not what I wanted. Plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 1/4, plus or minus 3/2, plus or minus 3/4. Yeah? It's in the back.
The couch in the back. Do you remember when he was running in between the rooms?
If you need to. Okay. Thank you. So, take a few seconds. I want you to turn to your neighbor, and I want to tell them what those numbers mean, what you just wrote down. What are those numbers? Then I'm going to call some people to share back. Thank you. Thank you. So, Reese, what do these numbers represent here?
Reese.
Sorry, Reese. Parker, are you still staring at you?
It's the possible zeros of the function.
Possible zero. What does that mean? Possible zeros of the function.
Well, it like when you do the synthetic division, it'll equal 0 at the end, and you won't have the remainder.
Did you hear that?
Yeah.
Can you repeat that?
I didn't really hear that. I was gonna. Never mind.
Can you repeat that so they can hear you?
Oh, I said that when you plug it into synthetic division, it'll equal 0 at the end, and you won't get a remainder.
Because you got a zero at the end.
Yes.
Did you guys catch that, Malia? That makes sense?
Yeah.
Yeah? Cool. Good job. All right, so let's do this. I don't want to, I'm not going to go through the slides any further. No, not yet anyway, because I'm going to test some of these. So I've got 4, 12, 0, 0, 1, and -3, right? Now this part, yeah, start with the easy one. Start with like 1. What?
It's negative one, dog. It's a negative.
Well, I want to show people what doesn't work. Okay? Oh, right here? Oh, that's what you're saying. My bad. Okay. Thank you. Thank you. We should do waterfalls. I learned waterfalls. You guys ever do waterfalls? Oh, I love the song too. But anyways, so like you know how I raise my hand, you guys be quiet. There was one. Yeah, it was. You see waterfall? So I went to this training. This lady, she taught in like Iowa or something. She tried to make it like a story like I love waterfalls. If you'll help me out, like dude, that's not what really the truth, but I like it. But their code word for being quiet was waterfalls, and when people do waterfalls, people would go shh. I thought it was fun. It's pretty elementary, but I was doing it every single time. I was like on spot, bro. All right. Thank you. So let's start by trying out positive 1, yeah? So if I try 1, I've got 4, 16, 16, 16, 16, 16. Oh my God. 16, 15. 15, right? And then I would get 15, and that's not a 0? So that means that 1 is not going to work. I'm going to make me a list of what I've already tried, because I don't want that bad boy. You guys want to try negative 1 now? I would do it just to eliminate the option. Does that make sense? So I've got 4, negative 4, 8, 8, 8, negative 8, negative 8. Where?
8, negative 8.
Oh, here, negative 8, negative 8. So that would be positive, positive. This would be negative 8, negative 9, positive 9. That's not, right? So plus or minus 1 don't work. What do you want to try next? Yeah, I'm trying my integers. So I'm going to try 3. So I've got 4, 12. Oh! What if we tried the negative? You think that would help us out here? Because that would carry a 0, wouldn't it? So let's do that. Let's go negative. That would make it negative 0, 0, 0, 0, 0, 0, negative 1, positive 3, 0. Yay! Now, so we have a 0, which is negative 3. Now, here's what's kind of cool about this. I need to find more, don't I? But now, whoa, go away. Now I can use these guys. I don't need to use the original one anymore. I got 4, 0, 0, 0, negative 1, and I don't need that guy because he's a remainder, correct? So now I can go back to my pit of stuff. I already know that positive 1, negative 1 doesn't work, right? Did we try 3? No, we kind of stopped, didn't we? And we said, oh, we should try the negative 3.
Can you not use negative 1 and 1 now?
No, because if it doesn't work for the first one, it's not going to work for the second one. Remember, it's a factor of the polynomial. So it's not going to work at all anymore. Let's try that 3. Do you think it's going to work for us? No, because I see it getting pretty big, right? How about half? Oh, that's a good one. But can you see how they kind of start jumping at you? I mean, not like literally, but positive 1/4. So I've got 4, 1, 1. Oh, a quarter, an eighth. Am I doing this right? Let's see. Yeah, quarter 4 is 1. That's 1, right? 1 times a quarter is a quarter. When I add them, I get a quarter. Oh, this is not correct. This one should be 1/16. 1/16. 1/16.
1/32.
That's not gonna work. You guys want to try the maybe 3/4?
Yeah, 3/4.
Maybe 3/4? But let me put my 1/4 in my not working list. Okay, so that way I don't try it again. And so let's try 3/4.
Yeah, try it again.
Hold on, I gotta erase this here, don't I? So here's my 3/4. So we're gonna go 4, 3, correct? That'll give me 3. That'll give me 9/4. 9/4. No, what did I mess up? That will give me 27/16. That's not gonna work, is it?
No.
Okay, so 3/4 doesn't work. What else?
1/2.
A halfer? Try a half? I thought we did a half. Oh, we did a quarter. We never tried a half. Oh, that's interesting. So 4. I think I suggested that though, didn't I?
No, I did.
2, 2, 1, 1, half, half, 1/4. That doesn't work. How about negative half? How about negative half? You think it'll work? I don't think so. So we have 4. What is that? Negative 2? Negative 2. 1, 1. Negative 1 half. Negative 1 half. Yeah, it's not going to work, is it? How about 3 halves then? Did we try? I know you have. I've been hearing you. But I want to show people that, yeah, we're going to be... You found my stuff.
Sorry to interrupt you, but I think that some of this might be what you're looking
Yes.
for.
No, this is to one of the old newcomers. But you know what? Thank you. Where'd you find it?
It was in Nevin's office.
It's in that.
So it's
Is there more cables in there?
That's what I saw. It was on the surface, and I saw the yellow of the pack.
Fantastic.
But it might be a case of getting a hold of him.
I will call
see
him.
if you can dig for more.
Yeah, thank you so much. Yay! We found some of my stuff. Our stuff, I should say. What are we doing? 3 halves? 3 halves. So I've got 4. 3 halves would give me 6. Right? So that's 6. And that would give me 9. Yeah?
No.
6 divided by 2 is 3. 3 times 3 is 9. Yeah.
Yeah.
So we got 9. Oh, that's not nice. That's not going to work.
None of them work.
Well, let's make sure it didn't work first, right? That's going to give me 27 halves.
And then 81 halves.
What is that?
I don't know. You tell me.
Oh, you know what? Hey. My bad. My bad. Here, I want to show you something before. Now, we can keep testing, but I just noticed something. What degree? Oh, hold on. Come back. What degree is this guy now?
Oh.
He's a 4th degree. So this guy is now 4x to the 4th minus 1. That is the difference of squares. So I'm going to get 2x squared plus 1, 2x squared minus 1. Correct?
You can factor the, wait.
That's another factor of squares.
No, it's not.
So it should have been. So why does the half work?
Yeah, it is.
The half should have worked.
Probably didn't.
Let's check it. Let's check it. 1 half.
Yeah, it's because.
That's 4.
And then 2.
Half of 4 is 2. That's 2. Half of 2 is 1. That's 1. Half of 1 is. Do I have extra zeros
No,
maybe?
you have 1.
That's what I was just saying.
Up here.
No. In the second. 4, 3, 2, 1.
4, 3, 2, 1. No, that's good. It is good. Huh. And this should give me a 1/4, which is not 0. Oh, but you know what it is?
Go get cocoa butter like a. It makes me.
Yeah, go for it. All right. So we'll come back. I'm thinking that this is. Here's what I'm thinking, guys. When we get to this, I think this one we won't. Thank you. We were only, this objective for this question was only to find those rational roots. But if we kind of took these and we used that 0 product property, this would give us x squared is equal to 1/2, correct? And when we take the square root of that, is that even an option? And when we do it over here, we're actually going to get an imaginary value, aren't we? Okay? So I think this example was meant only for doing this part, because that's how we really were doing, right? So let's go on and see if we can find another one. Here we go. So this one's actual solving. Go ahead and find me all the possible roots real quick. And I'm going to set up for synthetic.
Real quick.
It shouldn't be too many.
You want me to find all the roots?
Yes.
Like all?
All the possible roots.
Oh, you don't want me to like do it? Just the
No, we're gonna do it together.
All right.
Because I want to walk you through that. What's up, Holmes? Oh, yeah. There's a bucket right over there. I was just kidding. Put your ID on it. I never. Hey, someone took my pass.
You have to throw up.
No, I gotta use the bed.
What is it? Why would you ask someone who's about to throw up? You have to throw up. Yeah.
Is there only one?
Okay. It shouldn't take you too long.
Is it?
You should be done already.
It's 13.
What?
It's 13, isn't it?
No.
Never mind.
It's
1 over 13.
it's
13. Positive or negative 13?
positive or negative 13. Good. So which one do you guys want to try first?
Positive.
There's only 2 options, right? Plus or minus 13? Oh, that's true. And plus or minus 1. Thank you. Good looking out. What do you guys want to try first? 1?
1.
I like 1. 1. 1. What is that? Negative 5. Negative 5. 17? 17. Oh, there it is. Negative 13. Negative 13. 0. Hiya! Hiya! So, x equals 1. Let's do it again. We've got 1, negative 5, 17, negative 13. What do you guys want to try this time? Negative 1? Sounds good to me. So we've got 1, negative 1, negative 6, 6. That's not going to work. Check my work. Negative 6, yeah. I kind of did it, but I didn't write it. You're right.
Wait, positive.
What is positive 6? So, because negative gives us positive. So 23, it still doesn't work though. Right? Darn. Darn, darn, darny, darn, darn.
Where did you get this cocoa butter?
Walmart.
When? No, when?
I don't know.
You're supposed to throw it out after a year, but
It was last school year.
that's.
It probably doesn't handle the summer very well in here because it gets really hot. They turn off all the ACs.
I've been wanting to take the cocoa.
Okay, so negative 1 doesn't work. What else? What are we going to try next? We only have 2 more options. What do you guys want?
13.
Positive 13? What's up? And it's not? No, it's a negative 13.
Oh, I'm sorry.
Okay. Yay!
How are you?
What's 13 times 8? How much?
It's not going to work.
I don't know about that.
That's not going to work. Negative 13
That dude will be
is our last option. I feel like we should have more options.
I'm afraid that was.
Wait, did you do pasta?
I should have.
Okay. Thank you. Good. Okay, what do we got? 1, negative 13. That's going to give me negative 18. Positive. Ah,
That's a big one.
234.
4. I said that.
what is it?
234.
234. And that's just really, really big. We only got 1 of them?
Dude, there was only
The
one
rest
egg.
should be
I
imaginary
grabbed
stuff.
it. Use the power of graphing. I said cheese it. Use Cosmos.
I didn't even
No.
know.
It's so much easier though. Oh, why is
If I come to school and my hands are not lathered,
Well, you know what?
it's not gonna be a good day.
1 worked. Can we try 1 again?
right?
Because, could it work again?
That could be.
Because of
Science.
science? Because of what? Duplicity.
Oh, it's gonna work.
Duplicity. 1, 1, negative 4, negative 4, 13, 13.
Of course it's one.
Of course, we got it out.
I was thinking like, why we have too few options? Well, duplicity. So now we have 2x equals 1, correct? What is this now, a quadratic? So now this is x squared minus 4x plus 13. Is that factorable? No, but we can throw that into the quadratic. So x equals opposite b plus or minus square root of b squared 4ac all over 2a. Thank you. So we have 4 plus or minus something over 2.
No,
It's not?
no, that's correct. I just got the answer.
Oh, well, hold on for us. We have 16 take away.
That's not gonna work.
No, it's okay. I'm going to show you what we get. What does this end up being? 40 plus 12 is 52? Yeah? Yes or no? And what's the difference there?
Yes, we are.
What's 60 minus 52?
41.
Is it 41?
That's just what Jay told me.
No. 36. It's 36.
Thank you.
38.
We're all just like,
All right, so I've got 6i. Hold on. Thank you. So let's simplify this. This should become 2 plus 3i, correct? So here's what x equals. Here's how you're going to... So we know that x equals... Let me break this up because it's going to have 4 zeros, right? Plus 3i, x equals 2 minus 3i, x equals 1, x equals 1. So these are all my solutions for this polynomial.
That's awesome.
Questions on that? Because now we're going to go the other way.
Wait, no. No.
Oh, so we're gonna start from the bottom and read here.
We're going to start with the x's.
Okay.
Find the problem.
No, that was a good question. Someone wants to deal with imaginary. But thank you. Hold on. Let's wait for these people to quiet down because that's important. Go ahead.
I don't understand. Like, if they're not existent, why do we even include them?
I asked that same question to an engineer, and he says that they actually use a lot of it when they're creating, when they're doing electronics and stuff. That I comes up a lot. Now, I don't know the context of it, but it does. It's not really a. I know it's kind of mind-boggling. If we have time, I'm gonna show you a video. But actually, that dimension, imagine it. Have you ever seen XYZ coordinate plane? So when we're doing imaginary, that's kind of the idea behind it. You have XY, and then instead of Z protruding, it's I protruding. So when we're looking at parabolas, right, that have those imaginary values, you can imagine that kind of actually stacking itself and kind of coming out this way, as far as imaginary is concerned. I'll have to show you a video. I can't explain it very well.
How does it even exist if it's not imaginary? Like, how does it even have a thing? It's not a real number.
I understand what you're saying, right? Then that's why they're imaginary numbers,
Why?
and they're really hard to explain. But I'm gonna find you that video. I'm sure that with everybody. Probably tomorrow. A nice send off to vacation. Remind me, okay? Okay. So I want to make sure you guys are good here. You guys have gotten all of the values. We're okay testing those. Let's go the other way. You guys ready?
Wait, can I get a big picture of that?
Picture of this.
That's one page on Matt's document. How he makes them that long.
Oh, why did I take that on snap? My bad. Let me take another picture of this.
Okay, we're good? How much time do we have left?
You have 15 minutes.
to go the other way.
So that means we don't have homework.
I don't know if we're gonna have time to go backwards because I do want to show you this though. Can everybody graph that? You guys have a graphing calculator in front of you?
No.
Don't get up. It's gonna take too long. Who has the polynomial written down? The original one.
I do 4x to the 5th.
Slow your roll.
Oh, is that's what
4x
4x to the 4th power.
to the 4th power
Minus 6x to the 3rd.
minus 6x to the. Ah!
No, it's just x to the
No, I had this wrong. Hold on.
I know, just erase the whole
Oh yeah,
thing.
it's just x to the
Okay.
X to the 4th.
X to the 4th
minus 6x to the 3rd.
minus 6.
No,
I did it again. I know. I'm making my own mistakes here. Minus
6x to the 3rd.
6x to the 3rd
Plus 22.
plus 22
X squared.
Minus 38.
I don't know what you're trying to prove.
plus what?
Plus 13.
Okay. Now, based off of these zeros, what conclusions can you make? Turn to your neighbors just by looking at those zeros.
It's gonna bounce and then it's gonna be like it's kind of in there.
No calculators yet.
It's just gonna bounce. Yeah, I already did it.
Okay.
I did it from earlier.
Okay, my bad. All right, so I saw a lot of this. I saw this. So we're gonna have, it's gonna be facing up, correct?
Yeah.
So let's see what we know here so far. It's gonna be having this type of end behavior because it's positive, right? What else do we know?
It's gonna cross out. It's gonna bounce out one.
Over at 1, this parabola's gonna have to bounce, right?
Yeah.
So it's maybe doesn't look like that exactly. Maybe just kind of does this bit. What's gonna happen over here then? If I bounce,
It's gonna curve.
it's gotta have to do something like this.
Yeah, and then it's just gonna keep going up.
It's gonna have to do something like this. Now, why do I know it does something like this?
Because it's quadratic. It has 4 slope changes.
Right. So there's 4 slope changes. 1, 2, 3, 4. I have some imaginary values, which tells me there's a parabola that doesn't cross the x-axis, does it?
Oh, and that little loop.
Because of my imaginary values. This is my educated guess here. That's my educated guess. Does that mean that that's true? Not necessarily. Zoom, standard. I want to make sure. I knew I had some stats. Son of a biscuit eating bulldog.
Had you the first half, not going
Oh, so did we have that other dip?
Moist.
4. Okay, so here's our problem. So did we have that second piece? Maybe somewhere?
Maybe, yeah.
Bounced up.
Tell you.
It probably should exist. I would hope it exists.
This is where decimals is much more powerful.
Exactly.
Because then you can just move around and I'll tell you, if T.I. ever hears my recording, T.I., if decimals ever makes a handhill, you're out of business.
Honestly.
Dang, T.I.
Petition to make this most have a graphic on.
So I already know what that looks like up there. Oh, come on, don't be lazy.
He was so hurt on the bus when they didn't want to play.
I ain't never been out of Arizona, California.
Cool beans. Let's see what happens there.
Oh, no, I would like to like 100.
I'm not going to try to search for that. Okay, so let's go back to here. How much time do I have?
10 minutes about.
I have 10 minutes? Oh, that's plenty of time. Let's go the other way. I'm going to copy this. What did I do? Thank God for Control Z. Okay. So here's what I know, and you're going to get these type of problems. Hey, you know what? These are all the zeros. Produce for me the original polynomial. Where did it come from? Okay. So here's what we're going to do. You guys ready? I know that x equals 1, x equals 1, x equals 2 plus 3i, and x equals 2 minus 3i, correct? minus 1 minus 1. That means that x minus 1 equals 0. From here, I know that x minus 1 equals 0. Over on this problem, I'm going to get x minus 2 minus 3i equals 0. From here, I'm going to get x minus 2 plus 3i equals 0. Correct? Do you guys remember the zero product rule? That's what we did, right? We took every single term and we said it equals 0. So these are all zeros now. What are we going to do? We're going to distribute them all now. So once we do that, we've got x minus 1, x minus 1. Ugh. I know. Okay, so let's start here. What's this going to give me? X squared minus 2x plus 1. This one's going to be a little bit longer here. What's that going to give me? X squared. What's that going to give me? Minus 2x. What's this going to give me? Minus 3i. X, thank you. What's this going to give me now? Minus 2x. Then I've got plus 4. Then I've got plus 6i. Let me do the last one a different color here. What am I going to get here? Positive 3ix. This will give me a negative 6i. I'm running out of space. And finally, negative 9i squared. Okay, cool. So, let's see here. What can we cancel out? The negative I and the positive i's, those are gone. The positive 3ix with the negative 3ix, those are gone. And then this is actually a positive 9. Positive 9. So let's clean this up a little bit here. I've got x squared minus 2x plus 1. Now I have x squared minus 4x plus 13. And then I'm going to multiply the... Oh, I keep missing the button here. Now I'm going to multiply these two out, aren't I? So let's see here. I'm going to stack them. Is that cool with you guys? I like multiplying old school. So 13. What's 13 times negative 2? Negative 26x. And this will give me a positive 13x squared. Right? Let me move over a little bit. Okay, next value. I'm doing negative 4x now. So I have negative 4x, positive 8x squared, and then I've got negative 4x cubed. Doing the x squared now. I've got x squared positive, negative 2x cubed, and x to the fourth, right? So here we go. X to the fourth minus 6. Whoa, that should be a 3. 6x to the third plus, how much? 22x squared minus 30x plus 13. Ah!
Wait, how'd you get 22x squared and 30x?
I added everything up.
Oh, I didn't see those.
So now we're back to our original polynomial. Questions? Besides why imaginaries are so important.
Yes, I have a question. Why are not
I know. So we were able to go one direction. No pun intended. So we were to go in one direction and find all the zeros based on the polynomial. There it is. We found all the zeros. Some were imaginary, sad face. But then we were to take those zeros and create. Thank you. This will be on the test, yo. What a surprise. What a... Okay. Let me continue here. No, we don't have time to continue here. So someone remind me, we're on slide 9? We're on slide 9, Manana? Slide 9.